Morning, everyone. I hope all of you are keeping well. We are having an online session, obviously, because of the current situation with the pandemic. Of course, we cannot cover as much as we normally would in a one-day session where we meet together at some location. But this is the next best thing. Some of you may have joined another training about a month ago in September on reasoning and communication. Today, our topic is on differentiated instruction. I will start by just giving us some information, and then I will pause every now and then to invite you to ask questions. And in a 2-hour session, we are going to cover 1 or 2 examples to illustrate the principles of how teachers can help every student learn. People call that differentiated instruction, which is basically just helping every single one learn. A simplistic view of differentiating instruction is, if the students are weak, we let them do easy things. And the challenging content is reserved for the so-called advanced learner. That is an oversimplified view of differentiating instruction, and maybe even a wrong one. Hopefully, today's session will give us a little bit more ideas, a deeper understanding of how to make sure every student have equal opportunities to access the content they deserve. Meaning, even the weaker students should be given ample opportunities at challenging materials. Some of you might be thinking, how is that possible? This is the purpose of today's discussion. I will start by sharing my screen and showing you some data from research about helping all learners learn. All right, I will show you the screen, and then I will ask our colleagues from Mentari if you can see the screen, and please let me know. All right. I'm now sharing the screen. Can you see the screen, please?
Yes, we can see it.
Yes.
Hurry up. Yeah.
For those of you who want to get summaries and some of the slides, you can easily get it from my Facebook page. And I'm sure Mentari will also give you that information in your WhatsApp's group chat. Yeah. So if you just go to facebook.com/Banha Maths, you can get the summaries. You can also get the slides that I might be sharing with you. So once again, for those who are new to me, my name is Banha, and I work everywhere, but I work in Singapore schools, one in Singapore, and the other Singapore school is an international school in Thailand. I've been doing this for the last 10 years. And before that, I was training teachers at the National Institute of Education. And before that, I was teaching in schools. So I've been around education for about 30 years now. I will start by sharing with you some data to show us that actually every student can learn very well. This data is from the most recent TIMSS. TIMSS is an international mathematics and science study. And this is for grade 8 They also do it for grade 4. For grade 8, in the most recent study, Indonesia did not submit a sample. That is why you do not see information related to Indonesia. But you see, for the countries that we have available, 10 percentile. So 10 percentile score is the score of the bottom 10% of the group. Yeah, so we all are mathematics teachers. We kind of know the significance of 10 percentile is the upper bound, the upper value of the bottom 10%. In other words, the 10 percentile score suggests to us what the lowest students can do. In international studies like TIMSS, 500, a score of 500 suggests that the students are okay. 500, which is the international median, suggests that the students are learning what they're supposed to learn. They are not very, very good, but whatever they are supposed to learn in the curriculum, they have learned it. So is it possible for the weaker students to learn what is in the curriculum? The answer is yes, it is possible. Because there are many countries, including Singapore, where this is already happening. So the 10 percentile score for Singapore is a little bit more than 500. That means the weaker students in Singapore are learning what they're supposed to learn. Another point you may want to know is 40 marks, 40 points suggests 1 year of learning. So for example, in Malaysia and Thailand, the weaker students are a few years below expectation. For Malaysia, 353 is about 150 points below 500. Remember, 40 points is 1 year. So 150 points is almost 4 years. So a SM pay student, a lower secondary student, a grade 8 student in Malaysia is about 3 to 4 years below expectation. Likewise, in Thailand, where the score is 320 approximately, that is 180 points below, and that translates into 4.5 years below expectation. So we must be very careful. Students who are not doing well in school, if we are not careful, they will do very badly. But they don't have to do very badly. As you can see in some education systems in Asia, like Singapore, they can get to 500. In Taiwan, they are 1 year below. If you are 1 year below in secondary school, your teachers can still help you. But if you are functioning like a primary school student, 4.5 years below, it is possible to help, but it will take a lot of effort and highly specialized teaching to make those students catch up. In Hong Kong, the students are practically at 500, just about one term, just about 1/4 of a year below. Or in Japan, less than 1 year below expectation. Or in South Korea, almost learning everything, just a few months behind, which is reasonable. So I just want to share this data with you to assure us that it is possible. It is really possible for the weaker students to learn what they're supposed to. And at the same time, the advanced learners, they are not being held back. Advanced learners in Singapore, the 90th percentile, the top 10%, they are scoring at least 700, which is 200 points above expectation. Remember, 40 points is 1 year, so 200 points is about 5 years above expectation. Yeah, which is a lot, yeah? So they are functioning at a very high level. Those are students who are probably ready for college already, yeah? They can learn quite high level materials. You know, those students who often go for the Olympiad and competitions like that. So this is just the data to share with you that in differentiated instruction, the more able students are not held back. They get to learn what they need to learn. And the weaker students, they learn enough. They are not behind. And the average learners are doing quite well. The average learners in a Singaporean system is about 120 points above. So that translates into 3 years above expectation. So that is the outcome of differentiated instruction. I will now stop here. And some of you may want to ask questions. You can use the chat box function. You may want to share your views. You can also raise your hand if you wish to. All right, so over to you, Mentari, if people are asking questions.
All right, educators, if you wish to ask your questions, you may type those questions in the chat box. We invite you to ask your questions directly to the trainer as well by using raise hand feature, if you would prefer to do that.
Alternatively, you can also ask questions that participants have already submitted, yeah? Mm-hmm. So Ms. if there are questions you would like to share at this point, I'm happy to.
Mm-hmm. Sure. Maybe I can ask one of the questions that the participant have submitted. This is the question, Dr. Yap. How to reach the interest of students with weak abilities, especially the one with less confident, the ones who are less confident, they are too afraid to ask, or they have no idea to ask because the topic is a little bit unclear to them. Perhaps you can give some examples.
So in today's examples, I'll be illustrating how that can be done. In my answer right now, I want to share with you the philosophy behind it. If you want to cater to students who are not strong in mathematics, who are not confident in mathematics, what is very important is the classroom culture. How can we create a classroom culture that invites weaker students, reluctant learners, less confident participants to be involved in the class? How can we do that? Many of you who have attended previous courses already know the answer. The classroom for mathematics should always begin with a problem. Later, we are going to see examples of me doing that with you. Always begin by letting students explore a problem. Sometimes I call that problem anchor task. If you want to invite reluctant learners, always begin with exploration. Give them the problem, let them work it out with their friends. Usually I give them 10 minutes. How long is up to you? I usually give them 10 minutes, maybe some concrete materials, maybe not, depending on the problem, but usually with a friend or with other friends in a small group, 3 to 4. And then the second thing I do is I always gather them in front of the class. I like to discuss things with them when they're close together rather than them sitting everywhere in their seats. But that's up to you. I like to gather them. In Singapore, we have about 40 students. When I was a teacher 30 years ago, it was 45 students. But never mind, it's not that many. So we gather them in front of the class, they sit on the floor, and I say, group 1, tell us what you do. Group 2, tell us what you do. So the second thing is let them share their ideas. Sometimes I call that structured discussion. If you want to invite reluctant learners, make sure we begin the lessons like that. Exploration and then sharing of ideas. So that is my initial answer to that question. Later, for the rest of today, we are going to see examples of that in 1 or 2 problems from Think Mathematics. Anyone else would like to ask a question orally or through a chat box?
Yes, Dr. Yap, there's another question here in the chat box. How to grade a class as a whole using differential or differentiated instructions?
Differentiated the question is how to grade the class, how to give the class, how to give every student in the class a grade. Differentiated instruction is about teaching. It's not about grading. So we try to teach students so that the weakest one learn enough, the average ones are learning a lot, and the advanced learners are challenged enough. That is differentiated instruction. How do we grade students? I believe in Indonesia, you usually use a test. Your school might have examination. I think your question is, do you give different students different tests? The simple answer is, do you measure different people using different ruler? For example, those who have seen me, you know I'm not very tall. So you say, oh, Banha is a short guy. Let me use a different ruler so that he will appear to be taller. Of course not, yeah? When we measure people, whether the height or the weight, or in this case, achievement score in mathematics, we use the same ruler. We use the same ruler. So if your question is, do all students take the same test? The answer is, just like in teams, all the students in the sample took the same test. Differentiated instruction is teaching in a way to cater to all students so that they reach the same destination. If the assessment is different, you may say, okay, the weaker students take a very easy test, only basic questions. That means the weaker students did not get to the same finishing point. That is not responsible. We cannot systematically slow down any student. So good differentiated instruction is not teaching easy things to weaker students and teaching difficult things to advanced learners. If that is the case, you don't need a course because that is very easy to do. Differentiated instruction in the perfect format, in the perfect form, is everyone ideally get to the same finishing point. So the question is, do we give different tests to different students in differentiated instruction? The first answer is no, as I have explained in detail. My second answer, if there is evidence that some students, the weakest one, definitely cannot solve the most difficult problem, maybe 20% of the tests have very difficult problem, and you guarantee that some students in the class cannot do it, you must be able to have proof for that you can guarantee that at that point in time, even if you give it to them, they get 0. If you can have that proof, then under that special circumstances, those students can be given just 80 marks out of 100 to do. Actually, this is not unfamiliar to you. Those of you doing IGCSE, you know that there is the core paper and then the extended paper. That is an example of what I just mentioned in my second answer. So for students who definitely cannot do extended paper, guarantee they will then do the core paper. But that also means their highest grade cannot be an A. They will never get an A anymore. There is a ceiling to how many maximum marks they can get. Likewise, if your school is a school where there are gifted students, maybe 3 of them are highly gifted, they can take a special exam that no one else in the school take. So that's my second answer. If you can guarantee that the weakest or the advanced learners, they can do certain things that other people cannot, they can take a special exam. Again, this is not unusual. Many of your schools send your students, the advanced ones, for mathematical Olympiad. That is an example. So there are 2 answers. The common answer is no, everyone take the same exams. My second answer is, in special condition, the weaker student may not take certain part of the exam, the most difficult problem. And the advanced learners, they may only do, they are the only ones who do the difficult questions like in Maths Olympiad. All right? Anyone have a question you want to ask before I continue?
Dr. Yap,
yes.
Can I give a chance for Pak Kevin to ask his question directly to you?
Yes.
Okay, Pak Kevin, if you can unmute yourself and ask your questions directly to Dr. Yap.
Oh.
I think we're still waiting for him. Pak Kevin, can you hear us?
Maybe he cannot unmute himself. Maybe the organizer to unmute him.
Yeah. He is basically asking something about a change that is about to happen in his school regarding to assessment. So let's just wait for him. If otherwise, we can give a chance later, maybe. Okay, I think you can continue on for now, Dr. Yap, and then
yeah,
I
okay.
can...
So, Mr. Kevin, you can ask the question later when you have a chance to unmute yourself. So let me begin with the first example. All right, so I will do the problem with you. Some of you may have prepared for yourself square paper like this. You can use it if you want, or you can draw if you want. I will now demonstrate what I mean by creating a classroom culture that can invite everyone to learn what they're supposed to learn, right? All right, class. In today's lesson, we are going to solve this problem. In today's lesson, we have a square, and we are going to create a smaller square. So this is a smaller square. Just draw 2 lines. And this is a smaller square. All right? The area of the big square is a square of A, and the area of the small square is a square of B. So the big square has an area of the square of A, and the small square has an area of the square of B. All right? Use what you have. Use what you have and tell your friends what other information can we obtain about the area of the other pieces we have here. So we know the big square is a square of A, the small square is the square of B. Our problem today is, given those information, what other things can you say about the area of the other parts? Some of you may notice that there is a square here. Is it a square or a rectangle? I'm not sure. And then there is likely a rectangle here, a rectangle here. Are they congruent? Are they exactly the same size? I'm not sure. But our problem today is, what other information can we derive based on those two facts. Small square is a square of B, and the big square is a square of A. All right, so over to you now. And in a class, I leave the students alone for 3 minutes. But for the purpose of today's online session, as you find things out, you can share it in a chat room. Yeah, what else did you find out? Yeah, so over to you. Try to work it out, and then I will be looking at the chat group to see the kind of responses that you are getting. All right, so what other information can you get? So just continue working on it, and then share your thoughts in the chat room, and I will be talking to you as you try to do that. Yeah. So as you do this, let me just share with you what actually might look like in a classroom. So after the teacher present the problem, I would imagine they will collect the paper, and then they will work in a group, maybe in a pair. And for me, I leave them for 10 minutes alone. I do not interact with them. I do not interfere with what they do. I do not interrupt their conversation. So I basically leave them for 10 minutes, yeah, alone. I might be walking around, try to see what they do, try to listen to what they say, but generally, I leave them alone. So some of your friends are sharing ideas now. Somebody say, yeah, there is a square, and there are two congruent rectangles. And then they say that the lengths can be found. They even suggest doing subtraction. Is that true? And someone is suggesting the two rectangles, each has an area of AB. Is that true? But someone said no, the area of the rectangle is the difference of A and B multiplied by B. Someone else also agreed. And somebody said the two rectangles supposedly have the same area. Okay, you think so? Are they congruent? I mean, having the same area doesn't mean they're congruent, right? Are they congruent? If they're congruent, then definitely they have the same area. And quite a few of you are saying, yeah, the two rectangles have the same area. Some even say, yeah, they are congruent. And someone said the total area of the bigger square is known. Yeah. Is it A plus B square, the square of A plus B? So somebody is explaining in greater detail. So if you have a chance, try to read what our friend is saying, Mr. Newman. There is giving quite a detailed explanation. You can try to read what he wrote. And somebody begin to say, oh, it's a bit like completing the square. So some of you, for you, of course, you know, but the students, maybe they don't. So some of you in the class have learned something a little bit ahead, and you know something about completing the square. It's actually in book 3, but some of you are reading ahead and you know something about it. If you know something about that, you can explain it to the members in your group. I might say that to the students. So somebody say the area of the bigger square is A minus B squared, the square of the difference of A and B. And somebody is also giving some equations. The sum of A and B square, the square of the sum of A and B is the sum of square of A and square of B together with 2AB. So quite a few of different responses. I invite you to agree and disagree, because these are the things your friends say. I'm not saying they're right or wrong. And you don't need me to tell you it's right or wrong, because you can decide. Some of you are very sure, oh, this is wrong, that is right. Some of us are not very sure, but we can at least try to think, is that right? How can I check? You can always check with your diagram. You can always check with what you have in front of you. Some of you are drawing, some of you are using the paper. You can always check. If someone say the rectangle is the product of A and B. If someone say the area of the rectangle is AB, you're not sure whether it's right or not. Just look at your diagram and you can tell, is it true? The two sides are A and B. So remember, the information I give you is this. The whole piece, the whole square, the area is the square of A. So the whole thing, the whole area is a square of A. Yeah? And then I create a smaller square here by drawing two perpendicular lines. And the area of this is the square of B. So the whole thing is a square of A, and this is a square of B. Yeah, that's the information. Those are the information I gave you. Someone even say the big square and the small square are similar. Is it true that the one with square of A and the one with square of B, both of them are similar figures? And then they also say the rectangles are congruent. Yeah. So, colleagues, thanks for all your responses. If this is a normal class, when I'm with the students, I will spend 10 minutes, leave them alone, and then I will spend 10 more minutes doing the discussion like what I just did with you. The difference is, of course, in an actual classroom, you will be saying it to me. But now, because you're all muted, you only can say by typing in. Yeah. So that will be another 10 minutes. So this is what I meant earlier by exploration and structured discussion. So in an actual classroom, 10 minutes, no discussion, just the students working. And then 10 more minutes is doing like what I'm doing with you now. Yeah. I will stop here. I will stop here. So now coming back to becoming a teacher. What are some questions or observations you make about the lesson up to now, which is maybe about 15 minutes to 20 minutes in the actual classroom? Yeah, with you, I don't give you so much time, but with the students, it's about 15 minutes, I think, up to now. Yeah. Some observations, feel free to raise your hand, and then the host will unmute you, and you can share your views, or you can ask a question. I am now in the process of demonstrating how a differentiated instruction lesson might look like. Over to you now.
There is one response here. There are two congruent rectangles and two similar squares. That is an observation, Dr. Yap.
Yes.
Are there
anyone would like to share or ask question about the pedagogy? So that's the mathematics. That's the one the students are doing. So now coming back to becoming teachers. What are some observations you make about the differentiated instruction lesson? Or what are some questions you have based on what we just experienced, which is about 10 minutes of exploration, and up to this point, maybe about 5 minutes, halfway for the structured discussion. Anyone would like to ask a question? Would like to share something?
Can we please let Benisha M. Hutauruk to speak?
Yes, yeah, somebody from Mentari, can you unmute them, please?
Mm-hmm. Yeah, well, I think you can already speak up now.
Okay, I think that thank you for sharing the method now, because at the moment I'm actually doing the same thing with my students. Thank you so much. The idea that I get from what you have demonstrated to us just now is that for my weaker students, it's easier to see to use what she has learned before, he or she, like for example, using the formula for area of a square, formula for area of a rectangle, and then actually connected with the can be can actually work together with the stronger student to produce something, which I think the idea here is to give confidence, for her to gain confidence by sharing what she has known. Yeah, she has known before from the previous lesson. This is actually very, very helpful for me. I do have difficulties in explaining this kind of thing, but with this demonstration, I think it will be getting the students, the weaker one, to actually get into the discussion and feel confident that they can actually give something to the group and present in front of the class. Thank you very much, Dr. Yap.
Thank you. Thank you for that sharing. That's a very important point that you just brought up. When weaker students are given a chance to work on the problem in private with their friends, you are preparing them and hence giving them confidence later when the class meet as a whole. In a more traditional classroom where the teacher asks questions and want an immediate response, the weaker students have no preparation time. The weaker students have no chance to prepare themselves. In the format I just discussed, as pointed out by our colleague, the weaker students maybe cannot remember area of square formula, area of rectangle formula. They should, but they just don't remember it on the spot. It's not very difficult. Usually when they're in a small group, if they don't remember, their friend will say, hey, it's just multiply the length, just take the length, multiply together. And the weaker students say, yeah, I remember. So actually it's not a very difficult thing, but when the teacher used traditional approach, ask a question on the spot, the weaker students, because they're not prepared, they freeze. And over time, when that happens again and again and again, that will reduce the confidence of the students. But if you let them have a chance to work it out first, if they do not know anything, their friend will quickly remind them, because the things they need to know are also not very difficult. Like in this lesson, all they need to know is how to find area of square and rectangle and how to write basic algebraic expression. Maybe some of them don't remember, but actually they do. They just need a bit of time. So letting them have the time and letting them have other students to prompt them will increase the level of confidence, because this is done in private, in a smaller group. So when they come to the big group, they have more confidence to share some idea. Thank you very much for that. There is also a related question about this, which is, what if the weak students are not active in discussion and mostly just listen to the advanced students explaining? So I think what I said a while ago, based on our colleague sharing, give you some answer to that already. But I want to add one more point to this. Actually, sitting quietly and listening to the advanced learners is learning. Active learning is not always talking. There are some people who just don't like to talk so much. These are personalities that we cannot change. That's what makes humans interesting. If we're all the same, it's going to be quite boring, yeah? So some people just don't like to talk very much. Learning also involves listening. If they can listen to their advanced learners explaining, that is actually a model for them. So maybe they do not know how to do it. They have never seen it before. They have not seen how a person their age talk about difficult ideas. So the advanced learners serve as a role model. The weaker students at this point may not know how to do that. But when they see their friend doing that, maybe the friend draw a diagram to help the explanation. Maybe the friend fold paper to convince the class. The weaker students now have the idea, oh, I can do that. Next time, when it's my turn to explain things to other people, I can draw a diagram. Oh, this is how she used language. Very clear, very precise. She doesn't talk about other things. She go from one point to another. Oh, no wonder even I can understand it. Next time, if it is my turn to explain, I will also do like that. just talk about point to point. So if the weak students are not active, there's nothing to worry about because they are still learning. And in fact, they are using the advanced learners as role model. The problem is if they are not listening, if they are not engaged at all, yeah, the attitude, that will be a bigger problem. If they are not actively discussing, that is okay.
Dr. Yap?
Another question is, what should be the basis of differentiated learning, which is what I mentioned at the start. A very simplistic view of differentiated learning is weaker students learn easy things, advanced learners learn difficult things. As I pointed out, that philosophy is not entirely correct. The basis of differentiated learning is every learner get to learn what is in the curriculum. If the curriculum say everyone must learn the identity, the quadratic identity I just talked about, in the process of talking about, then everyone, weaker and stronger students, must all get to the same finishing point. The basis of differentiated learning is providing equal access to every learner. Everyone ideally should get to the same finishing point. Not some people get to the finishing point and some people don't. Not for your year, but by the end of the education process. So when they finish 12 years with us, everyone should get to more or less the same finishing point. Is the ideal basis of differentiated instruction. And some of you notice how this is done in the example I gave you. The whole class get the same instruction, but you see the responses are different. So students respond according to their current level. Some of them are ready for this, so they will say this. Some of them more advanced, they are ready for other things, they will say the other things. And some people notice, oh, that's completing the square, that maybe most people don't think about. But that student who know about completing the square get a chance to do the advanced thing that he is capable of. Yeah, so you notice how it is done. The same task that allow different people to respond differently. Joe Bowler from Stanford called this low floor, high ceiling task. So the floor is very low, meaning everyone can enter. Even the weaker students can start doing something. But the ceiling is quite high. That means the advanced learners can continue, even though they have mastered the basic very fast. Yeah. So that is what our friend Darius is saying. Make sure the task is common, but also make sure it is low floor, high ceiling task. Yeah.
Mm-hmm.
So quite a few other points. I leave you to read some of the things your friends are sharing. Yeah. Anyone would like to share your ideas orally at this point? And then you can raise your hand. Thank you for all of you who are sharing your views.
Mm-hmm.
Anyone would like to do it orally? Those who have written it in, I leave it for your friends to read your responses.
Dr. Yap?
Yes, please.
Can we perhaps give the opportunity for Mr. Kevin at this time?
Yes, anyone who, yes.
Okay. So could we please give access to Pak Kevin to ask his question to Dr. Yap, please?
Thank you, Miss Linda.
You're welcome.
Good morning, Dr. Yap and Mentari team and educators. So actually, my questions is a bit general. Let me read the questions. So we are actually going to make a change, and a broad change, like mentioned before by Mentari team, about the new education system, which is, I think, based on results. Do you have any suggestions, Dr. Yap, how we can actually initiate this change? I mean, like, how we can really what we can first do to to reform our teaching method, to reform the students' active learning. I think that's what I want to ask.
Yeah. So if your question is how do we reform our teaching, I think the answer is what I've already said. Start with exploration. Make sure every teacher in the school start a maths lesson by giving students a problem to explore. And then invite different students to share different ideas. So if the teachers want to make a start, I think that is the first step. Make sure exploration and sharing of ideas happen. And then after a few months, if the teachers are more comfortable, ask them to also do journaling. Let them ask the students to write notes. So maybe for today's lesson, my journal can be, all right, class, you have managed to get a lot of information based on the 2 information I gave you. Now for your notes, I want you to use everything we talk about to prove, to show that A plus B, whole thing square, and in this case, I'll write it down, is equal to the following 3 terms. The square of A, the square of B, and 2AB. And then if you have more time, you can also try to figure out an expression for the square of a difference of B, A minus B, the whole thing square, to see whether the expression is similar or different from the first one. So maybe I can give that for today's journal. So the second thing to reform our classroom is to let students keep a notebook. But you know, if you are running a school, it's difficult to change all the teachers at the same time. For the rest of us who are just teaching our own class, of course, it's easy for you to do. It's just you. But some of you are school leaders. You need to reform for your school. My advice is go step by step. Step 1, explore and structured discussion. Do that first. Once you are good at that, do journal writing. Let the students have a chance to keep a notebook. And then, when we are very comfortable, do a third thing. A third thing is reflection. Get the students to do reflection. Journal writing and reflection are differentiated in nature. Because when you say, write your own notes, the advanced learners will write better notes. The weaker students may write simpler ones, maybe even incomplete. Journal writing is differentiated because some students are very good in communicating. They can use diagrams, they can use algebraic notation to explain themselves. Some students, even though their maths is good, their communication is not good. So even though their maths is good, when they write their notes, nobody can understand them. So journal writing is already differentiated. The moment you say, make your notes, not copy notes, yeah? Copy notes, everyone get the same notes, yeah? Make your notes is automatically differentiated in nature. Also reflection. Reflection is also differentiated. People who are more reflective can see more things, can make more connections when they reflect. Some students are very good in maths, but reflection not very good. So even though their maths is very good, they need someone to tell them what to do. When they are independent, because of the inability to reflect, they are not so good at it. But their maths is very good. You tell them to do something, you give them a problem to do, they can do. But independently, because of inadequate reflection ability, they are not so good in directing themselves. So reflection is also a differentiated strategy. This morning, we have seen 3 strategies for differentiated instruction. 1, anchor task, a low floor, high ceiling task. 2nd, journal writing. 3rd, reflection. To reform your school, just start with 1, exploring and structured discussion. Yeah, so I hope that answers your question, but also summarizing what we are talking about today up to this point. I think one of them cannot raise their hand. Sharat, can the organizer maybe unmute our friend so that
Yeah.
They can share the idea because
Thank you,
I
Dr.
read. Yeah, please.
Can we please unmute Sharat Dita? I think he has a question for Dr. Yap.
Okay, hello, good morning. I want to ask, in the pandemic situation right now, okay, how to teach via Zoom, and how effective method for teach the mathematics, and how to manage the weak student, okay, in this situation. Thank you.
Yes. Two things I want to say. The question is how to teach through Zoom. Remote learning is not going to be permanent. Yeah. So do not think that from now on, this is what you're going to do for the rest of your teaching career. It's not. Yeah. It's just because of pandemic, and yeah, the pandemic will be settled hopefully as soon as possible. And then kids will go back to school. Yeah. Some things can be learned through technology, not everything. Today's session is too short, also not about teaching via technology. I will ask Mentari to share with you a YouTube channel. Jimmy King, my brother-in-law, he has a YouTube channel. And in that YouTube channel, I have some videos of me explaining how to do remote learning. So can I invite Mentari to share that playlist with the rest of the participants? And can you just go and watch some of the videos there to get the answer? Because today we have a very short time. Also the topics on differentiated instruction. If I answer that question, it'll take half an hour, and then you will not be able to cover today's topic. Anyway, the complete answer is all in the video, so there's no need for me to now say it to you, all right? So I invite you to watch that. Next, many of you are using Zoom. I know at least one school here, Mr. Kevin is from a school, Pahua. I'm not sure whether they are willing to share with you. But in the YouTube channel, you can see Pahua teacher trying, they are new to this, yeah, trying to use an alternate platform where they can see how other students are doing. It's not Zoom, it is a different platform. So I again invite you to go and look at how they have been doing it. If there's a chance, maybe you can communicate with someone from Pahua school, and they might be able or willing to share with you, yeah? So I let you do that, go and watch the videos of me explaining remote learning and some of the Pahua teachers doing remote learning using an online platform. Yeah, I do not want to spend any more time on that because the answers are all on those YouTube. Yeah, okay. There are many other questions from Miss Anna about the same question. Can I leave that to you? Okay. Anything else? Anyone would like to point out?
Hi sir, this is Sharad here.
Go on, please.
It is my proud privilege to hear you live, and from years we were seeing your books. So it is my proud privilege, sir. So I just want to ask, when we use differentiated learning in the class, at times I find that my advanced learners, they feel, even I give them a separate work, they feel that now they will finish in maybe 10 minutes. And for maybe rest 15 or 20 minutes, they just find time. So how to manage that? Do you have any suggestions for that, sir?
Yes, a very good question, I think. Many teachers give advanced learners more mathematics to do. And then you find out, oh, they also don't take very long. They finish it so fast. You see, they are already very good in mathematics. Why give them more of that? They are very good already. Are they equally good in explaining themselves? Some students very good in maths cannot explain themselves. So they are not good in explaining. So for that student, I need to help him become better in communication. So the additional work I give him is not more difficult maths problem. That's not what he needs. He's very good in maths already. I will give him some tasks, maybe write a note to explain to people how you can solve this difficult problem. Make sure your note can be understood by anyone. even people who are not very good in maths. Or some advanced learners are not good in reflection. They are very good in maths. So the extra time they have, I will use it to help them become better in what they are not very good at. This is the next principle of differentiated instruction. Colleagues, remember, we are teacher of mathematics, but we do not only teach maths. We also teach communication, ability to explain ideas. We also teach reflection, because those are part of doing mathematics. Many of us focus on learning mathematics, but we must also focus on how to learn mathematics, which include ability to explain and ability to reflect, and maybe other things. The second principle of differentiated instruction is make a list of important things. Example, the contents. What else? Reflection, communication, metacognition, visualization. For example, generalization, looking for patterns, generalization. So make a small list. That is my suggestion. Of course, you may have your own list. Make a list of what is truly important to you. Of course, the maths is important. Reflection is important. Metacognition is important. Visualization is important. Communication is important. Generalization is important. And maybe, shall I also say, attitude is important. I think somebody asked a question about students who have very bad attitude, and that's why they are not doing well. Yeah, I'm sure that is also common. How do we deal with that? Same thing. If the student need to improve maths, we deal with the maths. If the students need to improve communication, we improve the communication. When the student needs to improve attitude, we improve the attitude. So for that kind of student, you have to talk to them. We call that counseling, whatever you call that. You cannot ignore the student. Yeah? So that's my first answer. Some of your schools have special counselors, but some of you just do it yourself. But whatever the case is, you cannot ignore that student. Mm-hmm. There must be some deeper issue connected to why the student is having a bad attitude. I'm sure many of you know. Mm-hmm. Once the student like you, they will do whatever you want them to do. I'm sure many of you know that. So for that student who is very difficult, there must be some reason, nothing to do with you probably. But now the bad behavior is affecting you and the class and the student. Find a way to connect with that student. Of course, this is too short a session to talk about how to manage motivational behaviors, but that is something you have to do. Second answer. Some students have bad attitude because they find traditional lesson boring. Most students are very nice. Even though it's not very exciting, they will just go along with us. Yeah, I think you know that, yeah? Many students are very nice. They are very obedient. They are nice people, yeah? The lesson may not be easy. The lesson may not be exciting, but they will still do their part. They are well brought up. Their parents have told them, life is like that, yeah? Just suffer with it. Don't complain. Just learn what you can. And they do that, yeah? But not all students are like that. Some students have very strong personality. If they don't like something, they don't like it. And they will make sure you know they don't like it. Many students develop bad attitudes in instruction where they have to listen to a long lecture. They want to ask questions. They want to make their views known. So the teacher have to every now and then stop and say, anyone want to share your ideas? You must make it part of the lesson. So that's my second answer. Sometimes bad attitudes are developed because of the classroom culture. What I share with you today is what research have told us. This is the kind of learning experiences that can bring up the spirit of learners, meaning giving them better empowerment to share their ideas. Let them explore, let them share ideas, let them write their own notes, not just copy. Let them have a chance to freely reflect. So that kind of freedom is empowering. Many students are badly behaved because they feel very, I do not know the exact word, but they feel like they are stifled. They don't have the freedom. They want to speak up, they're not allowed. They want to write whatever they want to write, cannot, because the teacher said copy the notes. They want to have their own method, the teacher said follow me. So over time, they feel very frustrated because they don't have that academic freedom to do what they want to do. So sometimes bad attitude is also connected to that frustration of not able to have that freedom. Yeah? Anyone else would like to?
Like too many restrictions in a way, Dr. Yap.
Yes, too much restriction. Yeah.
Yeah. Okay. I know that there were 2 people raising their hand earlier. Now it's 3. Okay. Maybe we can give the opportunity for some of these people. Perhaps we can give a chance for Zetia Safitri. If the host can unmute Zetia Safitri, please.
Thank you for the chance, Miss Linda. I actually have an idea. Actually, I have done this before. I am teaching primary and secondary 1 students. So I have just did this with my primary student. I haven't done this with secondary 1 students yet. So we are in distance learning, right? So the task is given through Google Classroom. So by the time I asked them to solve 2 questions about fractions, and I asked them to answer step by step with sentences, like the way we explain the problems, and I want them to write step by step completely with the sentences. So that's what I did with my primary student, but I haven't done with my secondary 1 student yet. It's about explanation. So usually math homework is just about like question and then answer. So just a few weeks ago, I did this with my students, and perhaps I need to do this with my secondary 1 as well. That's all what I want to share. Thank you, Ms. Linda. Thank you, Mr. Yapanhar.
So thank you for that. I'm sure you have to do that with your secondary students as well. Yeah. I think you are right. When students are asked a closed question versus an open question. So thanks for that. This is a 4th way, a 4th strategy this morning, how to do differentiated instruction. Instead of asking a question that invite a closed answer, ask a question that invite open answers. Like today, I say, okay, tell us what you know more about based on the 2 information I gave you. I didn't ask you a closed question. A closed question will be, what is the area of the rectangle? Yeah. What is the area of the other square? That will be a closed question. I didn't do that, but instead I asked an open question. What else can you find out? So thanks for that. That is the 4th strategy this morning for differentiated instruction. This group is really good. We have a lot of interaction in the chat group. Of course, we like to answer as many questions as possible, but of course, in a 2-hour session, it's not possible. But I hope, Mentari, you are collecting the question. Maybe we can do screenshot. And then after the course, you can go to my Facebook, and any question I missed out or I didn't get a chance to answer, I will provide a more complete answer after the course. So this session, we only have a chance to address some of them, but keep the question coming. And I'm happy some of you are sharing your notes as well with the rest of the group. Yeah, summarizing for us various things we have learned about differentiated instruction based on what you are sharing with the group. Yeah. I will now continue. Is there someone else who want to raise their hand?
Probably not, but there is this question that kind of have been repeated. Would you like to take it now or a little bit later?
Okay, let's take the question. I see 2 hands actually.
Okay. So this question has to do with how to balance between the rigor of high school math with trying to accommodate for the mixed ability learners or doing differentiated instruction.
That question will be answered in my next demonstration.
All right.
Okay.
All right.
So
Sounds good. Okay.
Maybe I will unmute. I think Miss Devi and Mr. Ignatius have raised their hand. Can Mentari please unmute them?
Okay, I will unmute. I will send the name of the participant so our team can unmute this participant.
So I think two of them want to have raised a question.
Yeah, sure.
So in the meantime,
okay.
Already.
Okay, I think that's the first person.
Hey, good.
Okay, please.
Everyone, thank you for the
Hi.
hello, Dr. Yap. I do have actually two questions. The first one is, based on my experience, how do we avoid labeling when we apply differentiated instruction? Because in some cases, when we do apply differentiated instruction, some of students, especially who comes from the slow learner, they can easily identify, oh, I'm not that good, so I receive the easy questions, for example. So how do we avoid that kind of labeling? Because I think, as everyone agree here, student self-esteem is also one thing that we need to consider. That's the first one. And the second one, I do agree that differentiated instruction is not about the assessment, it's about the instruction itself. But my question is, how do we make sure when we apply differentiated instruction, we can make sure that all students will achieve the same level, because anyway, they will sit the same assessment at the end. Thank you.
Yeah. So thanks for those two questions. Leveling, yeah. So how to make sure students don't go away thinking that I am not good, so I get the easy question. You have seen it this morning. I asked the same question of everyone. I don't care whether you are very good, very advanced, or you are a beginner. I just give the same problem. Okay, today we have this big square. The area is this. We got a small square. The area is that. Can you tell your friends as much as you can based on the two pieces of information? So one of the answers is already given. By letting students know, by letting students have a low floor, high ceiling task. That means a common task. So they are all doing the same problem. Yeah. So basically the answer is in use open tools. Ask an open question or use open strategies like note making. Write your notes. Everyone is writing notes. I'm not saying, okay, you're clever, you do this. You're not so clever, you do that. I didn't. I said, everyone, write notes. Yeah. So that's the first, but a very big answer. If you want to avoid leveling, so some of you have this belief, and rightly so, self-esteem, use open tasks like note making, reflection, anchor tasks. These are open tasks. So you're giving everyone the same thing. Second answer. I'm sure every now and then you will say things like this. All right, class, as usual, we have learned today's lesson well if we can get one way to solve today's problem. I know, I always say we want to find more ways, but you have learned today's lesson very well if you have one way to solve today's problem or like today's lesson. All right, class, today we have heard so many things. You have learned today's lesson well if you are able to find the area of the rectangle and the area of the bigger square of the two. If you can find these two things, you have learned today's lesson very well. What I am demonstrating is the principle of setting the target very clearly. One way to make sure students are not the self-esteem part, yeah, to make sure you are not affecting students' self-esteem too much, is to tell them very clearly, this is the expectation. Many students develop negative views of themselves because they do not know what is the expectation. They imagine the expectation is the one that is the highest. So maybe the book got advanced problem, yeah? Those of you who use NSM, and think mathematics. We got the basic problem, intermediate problem, and advanced problem. If you don't tell them anything, student may actually think that I am supposed to do the advanced problem. I'm supposed to do everything in the book. And when they cannot, they don't feel good about it. That's because no one tells them what is the expectation. So for example, when I was a classroom teacher, my homework every day is the same. The homework is always, for whatever we learn today, do 5 problems. Yeah, do 5 problems from the textbook. Yeah, and I will say things like that. You have learned today's lesson well if everyone can solve problems from the basic section. The intermediate one, you try your best. Hopefully you can do it. But not to worry if you cannot. We have lessons tomorrow. And the advanced problem, if you find you want a challenge, you can do that one. But that one is not necessary for you to do it right now. So I always say that whenever I assign homework, make sure the basic ones you can do. If you cannot, I need to know. And then we can help you. Yeah. So make sure you can solve the basic problems. Intermediate, try your best. Advanced is to challenge yourself if you find everything very easy. So that's my second answer. To avoid leveling, set your expectation very clearly. So everyone who can do basic will know, okay, I'm okay. I'm actually okay. Many students who can do basic don't think they're okay because no one tells them that that is okay. So the setting of expectation is quite important if you want to make sure the weaker students feel okay about being able to do only the basics, because that's the goal. The basics is when they achieve the goal of the lesson. Intermediate is for a little bit advanced when you can apply the situation to problems, and advanced, of course, is for those who are ready for it. Yeah. I think Mr. Ignatius want to.
Yes. Yes, we have unmuted him.
Okay, thank you very much for the opportunity. My question is like the situation in the class, like you've said before from the data, is that some students are left behind around 4 to 3 years. So what should we do to make the gap between the students who are weaker and the students who are more advanced? Because in a class, in my class actually, there are some students who are really advanced, and then there are some students who are really weak, like the gap is too much. How do we handle that? And the second question is, yeah, actually I've tried the method that you've said before with the identity algebra. And what I found is that because of the gap difference between the weaker students and the advanced students, the weaker students really don't know what to do. Even though that I've already give some hints, their friends already explained. Probably that's because it's not the children's fault actually, because maybe the prior knowledge that they have is not enough. So, and then when I ask them to make journal writing, they don't have anything to write. I mean, I don't know what the problem is, whether they are missing words or they don't have any words to describe that. So I don't know, should we grade the journal writing, or is it just for us to reflect about what we have taught them? Thank you.
Okay, I'll try to answer as many of that as possible. Yeah. So journal writing, must you grade them? I think for Indonesia, you don't have to, because your Minister of Education already said no ujian nasional. So the whole idea, the whole direction of Indonesian education system now is less emphasis on grades. So I think consistent with that, I would recommend no grading. I would generally recommend no grading anyway, because you don't need the grades anyway. And if you are grading, actually you're going against the direction of the Indonesian education minister's recent announcement about the removal of the national test. Yeah, so that's about that. How to help them know what to do for journal writing, I'll answer that in my demonstration, the second demonstration in a little while. So I'll be showing how do we support people in journal writing, yeah? And then the big question, when the gap is too big, yeah? Several answers. Yeah, the first answer is the anchor task. You know the anchor task I gave you. The only thing they need to know is area of square, area of rectangle, something they learn in primary 3 if they use Singapore textbook. So this is now grade 8. I'm using something from 5 years ago. Okay, maybe they also need to do some simple algebraic writing. That's maybe grade 6, grade 7. Yeah. So if you want to cater to those with very big gaps, try to make sure the prerequisite is not too much. Like the example we saw, the prerequisite is area of square, area of rectangle. Yeah. Usually they would know, and if they don't, they can be reminded very quickly. Second answer. If you know some students need more prerequisite, ask them to go and watch some YouTube videos for things they need, but likely they don't have. So use technology for that. Either you prepare the video, or I'm sure nowadays there are a lot of very good YouTube videos on the relevant topic. For the students you know need those, tell them beforehand. Next week, you need the following things. In the meantime, go and watch the following YouTube videos. That's another way, and that's employing technology that is cultivating some independent learning as well. And quite suitable for remote learning at this point, yeah? Some things you just ask them to watch first, and then you do the lesson a week later, yeah? Next answer, when the gap is too big. Some of your schools have special programs. We call them remediation. So you can use the remediation, not to do the present year's topic. I see some schools have remedial lesson, but they are teaching this year's topic. But what they need is 2 years ago, the topic they have not yet learned. Yeah. So remediation is another answer. But some people have remediation, but they teach the current year's topic, which is not helpful. They need that to learn this, and they don't have that. And no matter how much you teach the current year's topic, it's going to be a waste of time. Yeah. So do remediation correctly. Yeah. Remediation is fixing what they don't have, not trying to teach them the current year's topic. That can be done, but in class. You already do that in class. Some people think remediation is a repeat telecast. It's not. Remediation is fixing the gap, yeah? So that's the next answer. Final answer is a big one. If those students come from your school, they are now in grade 8, and they came from primary school from your school, that means something is not right in your school. How come there are some students left so far behind and no one take notice of it and no one did anything about it? This will be, if I use the hospital analogy, the patient is neglected for 5 years. And then when you took over as a doctor, the patient died. The patient died not because he's supposed to die. The patient died because of negligence. So that's a difficult answer. That's a fourth one. And it's one that required the whole school to relook. What has happened? What has happened to make the students fall so far behind? Falling behind is natural, but no one paying attention to it and no one fixing it. That's a problem. It's very hard for you to fix now, but it is easy to fix every single year. If grade 3, something not right, you fix it. Grade 4, something not right, you fix it. By the time they're with you grade 9, the problem will not be that big. Yeah. So I give you different answers, and some easier, some more difficult one. Yeah. I will now continue with my next demonstration. I will share my screen now to continue with our discussion and also to answer some of the questions some of you brought up earlier today. Can you see my screen, Miss Linda? Can you see my screen?
Yes, perfect.
Thank you. Let me now continue with some discussion connected to journal writing and maybe other things that some of you want to talk about. But just before that, I just want to point out some data. You see, if we fix the problem every single year, by the time you get to secondary school, you can be sure that almost everyone can do the basics. So in this table, students who belong to this category, they can do the basics. In other words, they have the prerequisites. Students in the low benchmark in this study are those who cannot do the current material very well, but they can do basics. In other words, they have the prerequisites. The numbers are percentages. So I just want to share with you that it's not my opinion. It's actually data driven. I am not just sharing with you my view. It's something that is definite. You can make practically everyone, 99% of the student in a system, learn the basics. Yeah. Whenever they don't, it's because we don't do what learning theories ask us to do. We don't do exploration. We don't do structured discussion. We don't do note making. We don't do journal writing. We don't do reflection. Yeah. We don't do practice. We do drills. So usually when a lot of students are not learning the basics, yeah, when a lot of students are not learning the basics, it's because the classroom practices in the education system, not everyone, but a lot of people are not doing what research and learning theory say we must do. Yeah. So this is just data to say that what I shared with you earlier about everyone learning at least the basic, it's not just a fantasy. Yeah, it's a reality. It can be done. Let me continue now. This, by the way, is just a summary of everything we've been talking about today in bullet points. Let me now continue. All right, class. In today's lesson, we have tried to solve the problem about a square I gave you. And earlier today, for the first 5 minutes of the discussion, so many people share what they found out based on the two information I have given you. So we have a problem. We know the big square. We know the big square has an area of the square of A. And then we drew two perpendicular lines. And as a result, we created a smaller square. And for that one, we know the area is the square of B. And then I asked you, what else you found out? I forgot what your friend said. Anyone remember? Oh yeah, someone talked about similar figures. And they say these two are similar. Someone talked about congruent. And they say these two are congruent. If they are congruent, that means we can say the areas are the same, you know. Some of your friends suggested that the area of this can be found. And it's the same as this. Of course, this one we know the area, yeah? This one we know the area. It's given, yeah? And then some of you also say that the area of this can be found. All right? For note making today, at the very least in your notes, you need to show me how to find the area of this and the area of this. All right? So for those of us who have no idea what to write for our notes, we can say area of rectangle is, and then area of that square is. But you know, because this diagram got many squares here, be careful because people might not understand which square you are referring to. Yeah. So I leave that to you. Right, colleagues, I have just demonstrated what the teacher might do towards the end of the discussion. So to repeat myself, I give them the problem like I did, 10 minutes. And then I gather them, they share their ideas like the way you did in the chat room, maybe 5 minutes. And then I do this. And then next 10 minutes, they do their notes. They write in their journal. Okay, let me pause here. Are there questions in the chat room? Miss Linda, are there questions in the chat room?
Not at the moment. There is a response though. It's just about area. It's A minus B multiplied by B and the product of A minus B squared. There's also another, yeah. So another one is just this same kind of thing. So this person is completing the notes basically.
Right. So thanks for some of that. Some of your friends are very helpful. They are telling us that if we know this area, then we actually know how long this is and how long that is. So they are saying that, okay, that means this must be B and that must be B. I wonder if you agree or not. And someone say, oh, that means for the whole square, this length is A and that length is A. So they are saying, you see, if you know the whole thing is A and this is B, they are telling us, surely you know how long this is. And then they also say, actually, this one you know, yeah? You know how long it is. So because of that, we can find the area of this. Okay, maybe that might be helpful for some of us. So colleagues, sometimes the teacher can scaffold. I am doing differentiated instruction. So what I do may not be useful to everyone because they know it already. But it's useful to some people. So sometimes I do this only for some students who need it. Sometimes I do it with the class if I think that more people needs it. Yeah. So what I just did a while ago is another strategy for differentiated instruction. It's called scaffolding. So I was scaffolding for students to find the area of the rectangle. I can now demonstrate the same thing. Oh, some of us do not know the area of this square. But I wonder if we know how long the whole thing is. It's A, isn't it? And they say if you know the whole thing, and you know this one, that's B, isn't it? They say that if you know the whole thing, and you know this one, they say we can find this. Is that right? So again, I'm demonstrating scaffolding. This is the 5th strategy this morning, scaffolding. Yeah, thanks for that sharing. Actually, thanks for all your sharing because thanks to what you say, we have learned as a group at least 5 strategies for differentiated instruction. I'm not sure whether you have all the 5 listed down. You can share with each other. If you're missing some, you can ask in a chat room. Maybe some of your friends can help you complete the list. But the 5th one I just talked about is called scaffolding. And what I was doing a while ago is called scaffolding. Yeah. Anyone else brought up some points in the chat room? Miss Linda, or anyone else have questions you want to ask?
Not yet. Some people were asking about the app that you're using for all your notes. Some
okay,
of us are sharing.
The app I am using is called Note Shelf. But you don't have, I use Note Shelf because it's PDF, yeah? But actually you can use any app, example, bamboo paper. Yeah. There are so many paper app you can use. The one I'm using now is called Note Shelf. Yeah. It's just a simple paper app actually. It's nothing fantastic or complicated. It's just paper. I'm writing on paper. I'm writing on a screen. Yeah. All right. Some of you were asking questions like how to challenge advanced learners, how to teach the average learners. I want to say something. Many teachers focus only on mathematics. But some students are very good in mathematics, but they are not good in communication. They do not know how to present answers in an acceptable way. Mm-hmm. Some students are very good in mathematics, but they are not good in explaining. You ask them to stand up and explain, they will say, oh, they will just say the answer, yeah? They cannot explain themselves. I want to emphasize the concept of a multifaceted classroom. A multifaceted classroom, we value not just mathematical ability. We also value ability to explain. We also value ability to reflect. We also value the ability to lead a group. Some people not very good in maths, but they are very good when they lead a discussion for their group. That is a very valuable input. Many teachers say he is a good student. Actually, what we mean is he is good at maths. But some people are average at maths, but they are very good in explaining, or they are very good in reasoning, or they are very good in writing their journal, or they are very good in organizing their group. A multifaceted classroom value all those as much as mathematical ability. You see, the whole notion of differentiated instruction comes about because we put too high a value on mathematical ability. We may not say it, but our action, our silent messages suggest that. So many students think that if I'm not good in maths, I'm not good. And that is why we have to do differentiating. Yeah, but if the classroom value all those, then in the end, you have a student who is maybe very good in maths, but not very good in explaining. Or average in maths, but very good in communication. Or average in maths, but very good in organizing their friends. In a multifaceted classroom, we have a matrix. The maths ability may be beginner. Yeah, that's just approaching expectation, maybe meeting expectation, maybe exceeding expectation. And then there are also other things like communication, yeah, or things like visualization, things like can see a pattern, things like leadership, things like attitude towards learning. The list is up to you, yeah? You can have your own list. I suggested some. So in a multifaceted classroom, some students maybe not very good in maths, yeah? Maybe not very good in maths. So he's here, but he's very good in attitude and very good in leadership. So that child may be here. Or some student very good in maths, but not good in communication, yeah? Anything else you want to talk about before I wrap things up? Any other questions?
Dr. Yap?
Yes?
Can we perhaps address the question earlier about how to balance the rigor between, for instance, high school mathematics content and differentiating instruction in the class?
I think we just did that because here, when the students find the area of the rectangle, yeah, so they kind of know that this part is the difference between A and B, yeah. So they kind of know that that's the length of this, yeah. They will be writing down mathematical expressions, yeah, to say that, okay, the area of that is this. So the area of that is the difference of that multiplied by the other side. So they'll be doing things like that. So you see, at the end of the day, students are still writing down the rigorous mathematical expressions, yeah, that they normally do in high school mathematics. So what I'm saying is the appearance of things at the end of the day. How do things look like at the end of the day? It looked like mathematics in high school. There is no difference, yeah? So differentiated instruction is to bring students to the same outcome for everyone. So the outcome of high school mathematics is the rigor. What is rigor? Rigor is ability to explain themselves step by step, meaning the conclusion they make is rigorous. That means they will say things like, okay, I know this is the difference of the longer side and the shorter side, and I know this. So the area, I know the area is just that. And if I simplify it, I can get this if I want to. And then the area of the square, the area of this square that we talk about. Yeah, this one. We also know, we also know what that is. So they continue from there. Yeah. So there is not, I think what I'm trying to say is this: rigor means you can explain step by step how you arrive at the conclusion. And in differentiated instruction, that is expected. Do you see that? We are not saying, okay, differentiated instruction, the weaker ones, you don't have to explain yourself. We don't. In fact, we say that everyone must explain yourself. And maybe it's the weaker students who are better at explaining. Yeah. So there is really no inconsistency between the need to be rigorous with differentiating instruction. Basically, differentiating instruction is the way to get every student to become rigorous. You see, your advanced learners are good in maths, but sometimes they are not rigorous, meaning they just blurt out the answer. They don't explain themselves rigorously. Yeah, rigor in mathematics is basically that. Every time you make a conclusion, you justify yourself. That's what we mean by rigor. Do you see that in differentiated instruction, we expect that? Especially for the advanced learners who may not have that. Some advanced learners are superficially advanced, as in they can get answers very fast, but they do not have the rigor of providing evidence or justification for their conclusion. All right? Anything else before we come to the final part of today's discussion? Anyone else would like to share ideas, would like to bring up questions before I do the final wrap up? Any other question that Ms. Linda, you would like to share with the group? I see many things.
I don't think there's anything more so far in the chat box, Dr. Banhart, so you can continue on.
There is Mr. Reynaldo on
I'm sorry,
raise hand.
Oh, okay, okay, thank you. Hello, sir. Can you?
Hi, good morning.
Yeah.
Good morning. I would just like to share that I'm just so happy to hear from our speaker, Mr. Yip, who is a Singaporean. I'm just so happy to hear that coming from a Singaporean who criticizes, who is a critic of teachers being more particular in mathematics teachers being so particular in the content, the mathematics of what we teach, right? I mean, so much more focus on, say, what actually students can do in terms of communication, being able to explain themselves, which I observe in my classes. And I think what we have seen here is, which is I'm an advocate of, if we'd focus more on the beauty of mathematics, that mathematics is not just about formulas, right? If we'd focus more on explanations, that mathematics is actually beautiful, then we'll have more room for differentiated learning. And that's, I guess, if we're looking for materials so we can have more differentiated instructions, I guess we could focus more on explanations of mathematical principles, why Pythagoras theorem is like this, and how Pythagoras theorem is beautiful this way, in this way, and so we can have more, I hate to make stereotypes, but I mean, I think that's the general impression of Singaporeans. Like they're really good in mathematics. It's actually the first time I'm hearing this from a Singaporean teacher. I mean that we just cannot concentrate on the mathematics, the formulas and the technicalities of math. Maybe more students will appreciate math if we can present mathematics as a beautiful subject, when we talk about some explanations for some formulas.
Thank you for that. Yeah, I think that's a very nice, in a way, summary. You see why we even have differentiated instruction in the first place. Like, why do we even need this? We needed differentiated instruction because we make a mistake right from the beginning. We think that we are teaching maths. If we are only teaching maths, they don't need a human teacher. If I want students to learn factoring quadratics or factor theorem, I can direct them to some YouTube videos. Students can learn maths content from YouTube videos. We just need a few teachers in the world, and then they make some videos, and the students of the world can always learn from the videos. That's all we need. They don't need millions of us becoming school teachers anymore. Yeah, but we have made the mistake, not we, but as a society, for the longest time. We think our job is to teach content. No, our job is to bring up children academically. Bringing up children is parents' job, but academically is our profession. Our role is to raise children to become good in thinking, good in academic, rigorous ways of thinking. We are like your academic parents. We are not there to teach the maths. Yeah, we will teach the maths along the way. But our society as a whole, for the longest time, especially those of us teaching, have misunderstood our role. We always go into class, especially secondary teachers. I know because I was one. I always think that, I'm supposed to teach them chemistry. I'm supposed to teach them maths. And then when they cannot learn the maths, I blame them. How come their attitude so bad? I blame them. I should ask myself, why is their attitude so bad when they need to do academic work? It's my job. I am their academic parents. If their attitude in maths is bad, it's my fault. In a way, I wouldn't blame myself, but I will rethink. What can I do? What can I do to make sure that those two boys can become better in their attitude towards maths? If my top student in class cannot explain himself, I will not just say, you have to explain yourself. Go and learn to explain yourself, as if explaining oneself is God-given. It's not. It has to be learned. It has to be acquired. It has to be taught. They need to see role models. So if that bright child, good in maths, cannot explain himself, I need to do something about it. But our society as a whole, teachers in particular, sometimes will say, that's not my job. I'm a maths teacher. I'm supposed to teach maths. We don't need human teachers to teach maths. YouTube videos can teach maths. Our job is to teach a range of things. And I think this morning's discussion has brought us to this very important point, the multifaceted classroom. And that's why we differentiate. In a multifaceted classroom, there is the content. You got to learn quadratic. There is the attitude. And then there is a bunch of skills: metacognition, generalization, communication. There's a bunch of things, visualization. My job as a teacher is to develop those things: the content, the attitude, and competencies like visualization, metacognition, generalization, communication, number sense. Those are my three main jobs. Not just teaching maths, also developing attitude, belief system towards the subject. And also to develop abilities that support maths learning. Abilities that support maths learning, there are 5. Number sense, communication, visualization, generalization, and there's one more that I mentioned earlier. Do you have that? If not, you can check with your friends, right? So differentiated instruction is based on that. Mathematics learning, 3 big group of things to learn. And when a child did not learn one of those, different things. That's why we call it differentiated instruction. Differentiated instruction is not teaching difficult things to clever ones and making the weaker ones learn easy things. Differentiated instruction means different people need to learn different things because they are not very good at it yet. So maybe student A, very good in maths, okay in attitude, but not good in communication. That child needs instruction in communication. That is why it's called differentiated. Some people make the mistake. This student is good in maths. I give him more difficult maths problem. Sure, you can do that. But have you made sure the attitude is okay and communication is okay? If everything is okay, then sure, more difficult maths. But some teachers, without considering the attitude and competencies like communication, they give the student immediately, they give the student more difficult maths. Conversely, I have a student not very good in maths. I focus on trying to teach him maths, but I forgot he's very good in visualization. Differentiated instruction is he is not good in maths, very good in visualization. Can I use visualization to help him learn maths? That is differentiated instruction. Differentiated instruction is not, he is not good in maths. I try to teach him easy maths. Differentiated instruction is he is not good in maths, but he is good in something. What is he good at? Oh, he's good in explaining himself. Can I now make use of language explaining himself to help him learn maths? That is differentiated instruction. Yeah. So today's course is to give us as a group a higher level understanding of differentiated instruction. I will now share my screen and then do a final example, and then invite participants to share a bit of reflection or maybe ask final questions about the topic as we wrap things up. So some of you may have questions connected to word problems. Both the examples I did today come from new syllabus mathematics, but the new edition has a new name called Think Mathematics. Likewise, this problem is from Think Mathematics, secondary 1. Some of you are using this textbook already. Yeah, so here is a word problem. Let me use the final demonstration to summarize, but also to provoke you into thinking and maybe raising final reflection points. Again, feel free to share. I'm sure Mentari will collect your questions and your sharing and share them with me so I can make sure all your questions are completely answered, because, you know, short session, we cannot address every single point you raise. Let me demonstrate. All right, class. In today's lesson, we are going to solve a problem. As usual, you are going to have about 10 minutes afterwards to talk to your friends
Dr.
But
Yap.
before that, yes.
Sorry to interrupt you. Have you shared your screen yet with us?
Can you see your? You cannot see my screen. Okay.
I can't see it yet. We can't see it yet.
I'm sorry about that. Can you see it now?
No, yeah. Now we can see it.
Okay,
Case
thank you
study
for
too.
that.
Yeah.
Right. Thank you for that. All right. So, all right, class. In today's lesson, we are going to solve a problem, and today's problem is about some friends. Do you know who is in the story? And do you know what is it all about? A few sentences. There's one sentence. There's another sentence. Oh, only two sentences. And then we have the question, yeah? So a very short story. So we need to find somebody's age, yeah? Oh, they say present age. Present age means what? Yeah? Can you tell your friend what does present age means? What do people mean when they say present age? It's a bit unusual, yeah? But here they say, what's your present age? Yeah. Anyway, you can tell your friends that. Let's focus on the information. Nadia is twice as old as Raju. It's very long, so maybe I focus on this. Nadia is twice as old as Raju. Can you calculate? Can you calculate something? Maybe yes, maybe no. If not, maybe can you draw? Some of you are familiar from primary school. Draw models. And for those of us who like to use expression, some algebraic expression, can you write some expression? I leave it to you. If you think you can calculate, go ahead and calculate. If not, it's okay. Maybe you can draw. And if you are drawing, are you going to use 1 unit for Nadia or 1 unit for Raju? And then those of us who like to write expression, what would you like the x to be, the unknown, yeah? I'll leave it to you. Another information we have is Nadia is half as old as Bernard. Nadia is half as old as Bernard. So Nadia is half as old as Bernard. I wonder who is older. Can you calculate? Can you draw? Can you write expression? All right, I'll leave this to you. For the rest of the time you have with your friends, you also need to deal with in 22 years' time. What will happen? Something will happen. Bernard will be twice as old as Raju. Right, so I have just demonstrated what I mean by scaffolding. Right, I did not solve the problem. Yeah, I will leave you to solve the problem. I think solving the problem is not a problem at all. Yeah, so I want to use the remaining time for you to ask questions. In case study 2, I demonstrated scaffolding when the teacher is presenting a problem. Yeah, in this case, a problem from the textbook. And then the students have 10 minutes to try to solve the problem as much as they can. Some students solve it completely, maybe 2 methods. Some people cannot solve it completely. Some people can, but only 1 method. Yeah. And then again, I will gather them and get them to share their ideas. Yeah. And then after that, all right, class, before you go back and write on your notebook, for those of us who use drawing, what do you let the unit be? Do you think it's better for the unit to be Nadia's age, Raju's age, Bernard's age? Not sure. I'll let you decide. For those of us who want to use variable x, do you want the x to be Nadia, Raju, or Bernard? Okay, I leave that to you. Different people have different opinion. Some people say, I want this to be Nadia. Is it good? Maybe it is. So if Nadia is this, can you draw Raju's diagram easily? Some of you say yes, some of you say no. If this is Nadia, can you draw Bernard's diagram easily? Some of you want this to be Raju's age. I'm not saying this is the best, but I want to try this. If I let this be Raju's age, can I draw a diagram for Nadia's age? Nadia is twice as old. So if I know Nadia's is twice as old, can you imagine how the diagram might look like? I think you can. Afterwards, in your notes, can you complete this? Nadia is also half as old as Bernard. So Nadia is half as old as Bernard. So if you know Nadia's diagram, can you imagine Bernard's diagram? Nadia is half as old as Bernard. Okay. All right. In your notes, can you complete the model? And then afterwards, write down the algebraic equations that lead us to the solution to answer the question, find Nadia's present age. All right. The rest of the 10 minutes is for you to write the notes. All right, colleagues, I have just used this example to summarize, to bring us back to some of the things we talked about the whole of this morning. I want to stop here for you to share, for you to bring up final questions that you might have. All right, over to you. Ms. Linda, is there any questions from the...
Yeah, there was one question, Dr. Yap, from Mr. Amir. Perhaps if we can unmute Mr. Amir so he can ask directly to Dr. Yap.
Hello, it's nice to talk to you, sir. What I was wondering is, if you give different instructions to different students, and once they end up taking the real test at the end, because it has to be a standard test, right?
Yes.
What happens is, those students that we have been encouraging and patting them on the back, telling them they are doing their very good job, and when they find themselves faced with the questions that they cannot solve, won't they feel like that teacher didn't teach them enough to solve the question that they gave?
Right. So when you do a test, your test will have a bunch of basic questions and a bunch of intermediate questions. Usually that will make up at least 80% of the test and maybe 20% of advanced problem. Our job is not to make sure everyone get 100 marks. That's impossible. That is why we need differentiated instruction. Different people are at different level of readiness. What is not acceptable is to have a lot of students cannot even do the basic. Our role as a teacher is to make sure everyone master the curriculum, at least at the basic level. And then a lot of them can do the intermediate levels. And then some of them, hopefully as many as possible, but not compulsory, some of them can do the advanced. So on a test, the students would know. Why? Because you would tell them every day. Remember, I was reminding the group that whenever you give out homework, make sure you set your expectation. Don't just say, go home and do your homework. Tell them, today the homework, there are some basic, some intermediate, and everyone must be confident with the basic. If you're not, I must know. Let me know, and then we will work with you. But otherwise, everyone should be able to do the basic. And most of us should be able to try to do the intermediates. But some of us cannot at this point. that's okay, but make sure your basic you can do. Intermediate, you try your best. And then for those who want to challenge yourself, you can try one advanced question, but that is optional. So I would set the expectation every single day. So students will know on the test, all the basics I can do. And the intermediate, by the time the test comes around, I can do a lot of them. In other words, I must be able to do most of the question. But the one or two advanced problem, maybe I'm not ready for it. I will give my best because I got a good attitude. But sometimes even though I try, I can only do the first part. So maybe out of 5 points, I get 2 points, I get 3 points. Yeah. So that is the answer to the question.
Yeah, there's another one, Dr. Yap.
Go on.
This is the question. Is that true? The key of metacognition, especially in teaching word problem, is questioning.
Scaffolding. The question is it true to help them with the question? The metacognition is questioning. Answer is yes, but there are others. How do we scaffold? So this is very important. Yeah, this is the 5th strategy we learned this morning. Yeah, scaffolding. And thanks to you, now we can finish it up. How do we scaffold? You are right, questioning. I think you noticed that, yeah? How else can we scaffold? Diagrams. You notice I use diagrams a bit anyway. In both the examples, diagrams is another way to differentiate instruction when you do scaffolding. Yeah, diagrams. What else? Concrete material when it's necessary. Like for the first example, I used paper, but second one, I did not. So sometimes when it's possible, concrete materials. Next one, scaffolding, time. Do you notice I spent a lot of time on one problem? All the time we were solving one problem, you know. Exploring, one problem. When they discuss, same problem. When they make their notes, same problem. And then when they do the practice afterwards, they can try maybe 3 to 5 problems and maybe 3 to 5 homework problems. So during the practice, they do a lot, maybe 10 problems. But during the learning, it's one problem. So thank you for that. The 5th strategy we learned this morning for differentiating instruction is scaffolding. How can we do scaffolding? Questioning, concrete materials, drawing diagrams, giving them time. Finally, friends. I think some of you mentioned that. When they work with their friends, the friends can help them, the friends can model for them, the friends can motivate them. Yeah, friends, the safety zone where they can work without fear of saying silly things. In a big group, maybe they're a bit shy, yeah? But in a small group, they say silly things, they laugh about it. It's like no big deal, yeah? So I think this is where we end. This morning, we have heard 5 differentiated instruction strategies. Actually, most of them from your friends. Yeah, thanks for that. And actually, we discussed quite a lot of things, including the more difficult philosophy of differentiating instruction, which is going beyond easy things for weaker students and difficult things for advanced learners. Quite a lot of things. And thanks to the group, thanks to those of you who raised those questions. All right, I'll now pass it back to Mentari. If there's anything else, if not, it's conclusion, yeah? All right, Ms. Linda, over to you.
All right. So thank you so much. Are you finished with your conclusion, Dr. Yap?
Yes, I'm finished my conclusion, but I just saw one important question came out. And in my opinion, is it true that some area of mathematics are hard to visualize? Yes, mathematics is inherently abstract. It's generally hard to visualize, especially the harder content it is. That is why earlier today I said, don't forget, teach visualization. Remember the list of things? Visualization, communication, metacognition, generalization, number sense. Don't just teach the maths. Develop the attitude and develop these 5 things. This is our complete job. So it is important in differentiated instruction to develop visualization. Otherwise, your advanced learners, when they need to visualize difficult things, they don't have the visualization skill. So you are right. Some content are harder to visualize. That is why we must differentiate instruction to make sure everyone is good at visualization. Because some students are very good now, but they are not good in visualization. If the teacher neglect visualization, then the successful student will no longer be successful next year or 2 years later. All right, I think that's a very nice question to kind of remind us the three components of our job in a differentiated instruction. Yeah, that's all I think we have time for, Miss Linda. So back to you.
Yeah, thank you. So I have to end the Q&A session, but do not worry. Should you wish to send your questions to us, you are welcome to send them to the following email address or WhatsApp number. So that is the contact where you can send your questions. So thank you very much again, Dr. Yap. I trust that the participants are more equipped to accommodate the learning needs of mixed ability learners in their classes. So now, educators, it's time for photo session. Please turn on the camera or your video for a little while so we can take your pictures together. Prepare your best smiles. And Mr. Ludi, can you please help us in this photo session? Thank you.
Okay. Mr. Hijri, can you please slideshow? Okay. I will take a picture, yeah, everyone. Okay. I will take around five times because there are a lot of participants today. Okay, I will take the first page, yeah. Okay. 1, 2, 3. Okay. Another pose, everyone. Okay. 1, 2. Okay. Wait. Okay. 1, 2. Next. Okay. 1, 2. Okay. Next. 1, 2. Okay. 2 more. 1, 2. Okay, 1, 2, and okay, Miss Linda.
All right. Thank you, Mr. Ludi, for the photo session. These photos will be sent through the WhatsApp group. And a final reminder, the digital note for today is also accessible through WhatsApp group. So now we are ready.
Sorry, sorry, Miss Linda. Can we take again? One more? Okay.
Okay, one last one.
Yeah, yeah,
okay.
okay. Sure. Okay. Mr. Hijri, please share screen. Okay. One more time. Mr. Hijri, okay. Wait, yeah. 1, 2. Next. Sorry. It will take a long time. Sorry. 1, 2. Okay. 1, 2. Okay. 1, 2. Okay. 1, 2. Okay. Okay, thank you, Miss Linda.
Okay. So please kindly, we are ready for the feedback time now. So educators, if you could spend the next 2 minutes to fill out the feedback form, that will be very helpful. The link and the QR code are displayed on the screen and it will be sent. I think it's already in the chat box as well. So if you may, if you can please click on the link and fill out a feedback form for us, that will be very helpful. And this is important. Please access the online form and make sure to fill it carefully with your full name and active email address, as the digital certificate will be sent automatically via email. Bapak dan Ibu, saat ini sudah tertera di layar tautan feedback online dan QR code untuk Bapak Ibu isi. Kami berikan waktu 2 menit ke depan untuk bisa mengisi form tersebut. Silakan.